So for this next video, we're going to talk about the work energy theory, talk about work in general, the equation for work, and then do example problem number 30. So we'll start out by talking about the equation for work. Work equals force times distance. And it also equals the change in kinetic energy plus the change in potential energy. So say if there's no potential energy, then it's just going to be work equals change in kinetic energy, right? So we should remember that. And we should remember that for kinetic energy, we can show that kinetic energy equals 1/2 mv squared. So a change in kinetic energy, change in Ke, will equal 1/2 m1 v1 squared minus 1/2 m2 v2 squared. So that all that's saying is just the change in kinetic energy, just finding the difference between the two. And now we're gonna go. Oh, one more note about this. So this formula shows the change in kinetic energy being equal to being equal to work. So that off of this, we know that moving a particle side to side, so not up and down, that doesn't change its kinetic energy or potential energy. That moving a particle side to side requires zero work, no work. So that's just something to remember. So now we'll go on to the example problem number 30. How does the work required to accelerate a particle from 10 to 20 meters per second compared to that required to accelerate it from 20 to 30 meters per second? So we're going to think about this and use our formula equals change in kinetic energy plus change in potential energy. We can write potential energy as U. So we know that there's actually not going to be any potential energy in this, so we can just write it as change in kinetic energy. So what we'll do is we're just going to compare the two. So at first we'll do the change from 10 to 20, so we can do 1/2, and for this we're just going to assume the mass stays the same, m20 squared minus 1/2 m10 squared. So that is going to equal 1/2 m400 minus 1/2 m100, which equals 200m minus 50m. You can see that. Now for the second one, we're going to do 20 to 30. So we're going to do 1/2 m30 squared minus 1/2 m20 squared. We can write that right there. And that's going to be equal to 1/2 m900 minus 1/2 m400. And that's going to be equal to 450m minus 200m. So that means the top one is equal to 150m and the bottom one is 250m. So that means the change in kinetic energy is equal to work. So when it's going from 20 to 30, it's 100 greater because 250 is greater than 150. So now we can see what's the relationship between 10 and 20 compared to the 20 to 30. So we know 20 to 30 requires more work. So we can say the 10 to 20, it is less, which is A. And that's the video.